Welcome. Today we discuss few problems on the chapter limit and continuity. Let us take the first problem as limit x tends to 0 sine of x square plus 4x divided by x cube minus 5x square plus 2x. Options 3, 2, 1, 0. About trigonometric functions, we have the only formula sin x by x. If it is sin x, then it is x, or rather sin mx by mx, it is again 1. So in this case, it is not directly sin x by x of that type. If we take x square plus 4x is equal to y, then as x tends to 0, y, it is 0 plus 0 is y also tends to 0. So that we can write like this: limit x tends to 0 sine of x square plus 4x by x square plus 4x into, now we have to adjust it, limit x tends to 0 x square plus 4x by x cube minus 5x square plus 2x. So this cancels this by that. Now just now, as I told you, that if we take this is y, this is also y, and as x tends to y tends to, as x tends to 0, y also tends to 0. So that it is equal to limit y tends to 0 sine y by y into limit x tends to 0 x square plus 4x by x cube minus 5x square plus 2x. This is 1 into. From numerator and denominator, one x can be cancelled. Limit x tends to 0 x square x plus 4. After cancelling x, this is x square minus 5x plus 2. Now, putting x is equal to 0 over here, this is plus 4, this is plus 2. So that 2, 4 by 2 is 2. So this option is correct. Our next problem. Limit x tends to 0 sine square x plus cos x minus 1 divided by x square. Options are minus half, plus half, 0 and 1, and that problem was given in (10). Actually, by putting directly x is equal to 0, this is 0, 1, minus 1. So it is 0, 0. So 0 by 0. So we have to either use some formula or by L'Hospital rule, we can get the limiting value very easily. If we try to use formula sin square x by x square limit x tending to 0, that would be 1. And then plus x tending to 0 cos x minus 1 by x square, uh, expressing this in terms of sin square x by 2, very easily we can get that. But I am using here L'Hospital rule. It is of the form this by that. In examination, no need of mentioning what method you are adapting or taking. No need of in rough. Somehow you have to do that. In L'Hospital rule, derivative of the numerator, sin square x, it is 2 sin x cos x. Cos x, derivative of cos x is minus sin x, and that is 0 divided by 2x. So that it becomes x tends to 0 sin x into 2 cos x minus 1, 2 cos x minus 1 by x. First part, sin x by x tending to 0, it is 1 into limit x tending to 0, 2 cos x. Oh, sorry. 2 cos x minus 1 divided by x. So it is of the type minus sin x. Okay, sin x taking common, 2 cos x minus 1. Just 1 minute. I'm just looking over the problem. Cos x minus 1 by x square. Okay. So its derivative is 2 sin x cos x. Its derivative is minus sin x by 2x. Okay. Now sin x taking common, 2 cos x minus 1 divided by x. So it is equal to this sin x by x into this sin x by x into x is already taken here. Sin x by x, it is 1 into this. Now putting x is equal to 0, it is equal to 2 minus 1, that is 1. So that it is equal to, again and again I am mistaking. It is 2x is there, so it is 2. So that 2 is there. Once again I am repeating. Sin x taking common, 2 cos x minus 1 by 2x. Now sin x by x, it is 1 into limit x tending to 0, 2 cos x minus 1 by 2. Now putting x is equal to 0, this is 1 and this is actually 2 minus 1, that is 1 by 2. So 1 into half is half answer. The next. Actually, where L'Hospital rule is applicable, you can use that because it will take less time, I think. Next problem. Limit x tends to 0 by 1 minus 1 plus This is also 1 plus 5x square by 1 plus 3x square whole to the power 1 by x square. X tends to 0. And its options are e square, 1 by e, 1 by e square. And that problem was given in WB JEE 10. Now, this can be written as this problem is equal to limit x tends to 0, 1 plus 5x square to the power, this is 1 by x square, you see, to the power 1 by x square by limit x tends to 0, 1 plus 3x square whole to the power 1 by x square. Now, we have one formula like that. Limit x tending to 0, 1 plus mx whole to the power 1 by mx is equal to e. Now, this one is of the type as x tends to 0, x square tends to 0. So, limit x tends to 0, 1 plus 5x square to the power 1 by 5x square. Because to avail the formula, it must be 1 by that. Now adjust. It is 5. 5 cancels 1 by x square. Similarly, in denominator, limit x tends to 0 by same approach 1 by 3x square whole to the power 3. Now it is equal to e to the power 5, e to the power 5 by e to the power 3. So that e square is answer. So that second option is correct. Now take the next problem. And next problem is limit x tends to 1, sine e to the power x minus 1 minus 1 by log x. Limit x tends to 1, this by that. And its options are 2e, 1 by e, e and 1. And that problem is given in this. Acha, okay. You see, as x tends to 1, this is e to the power 0, means 1 minus 1 is 0. So sine 0 is 0 by log 1 is 0. So it is of the type 0 by 0. We can use formula or you can use L'Hospital rule. As because it is of the type 0 by 0, we apply L'Hospital rule and it is equal to derivative of the numerator. It is basically sine function, derivative is cos of e to the power x minus 1 minus 1 into derivative of that part is e to the power x minus 1 by 1 by x, so that it is equal to limit x tends to 1 x into cos of e to the power x minus 1 minus 1 into e to the power x minus 1. So by putting x is equal to 1 is become 1. This is cos of e to the power 0 means 1, 0. Cos 0 is 1. E to the power 0 is 1. So that it is equal to 1 into cos of 0, 1 into e to the power 0 is 1. So that it is 1. So that option is correct. In one step, we get the result. Next, next problem is limit x tending to infinity root over s square x square plus ax plus b minus root over of s square x square plus b, a not is equal to 0. What is the limiting value of that? Options: half, 1, 0 and 3. And that problem was given in the year in the 2007. So by putting x is equal to infinity, given that a not is equal to 0, so this become infinity, this is infinity plus b. So root infinity is infinity, that is also infinity. That is infinity minus infinity, that is not defined. Infinity minus infinity, it is not defined. For that purpose, rationalize it. It would be equal to limit x tends to infinity root over of s square x square plus ax plus b minus s square x square plus b into its opposite sign root over of s square x square plus ax plus b minus plus its positive sign root over of s square x square plus b divided by, we have to adjust, that is we have to divide by that, so that it is equal to s square x square plus ax plus b plus b. Now in numerator it is of the type a minus b into a plus b. So s square minus b square. So that s square x square plus ax plus b minus s square x square plus b. That divided by root over of s square x square plus ax plus b plus root over of a square x square plus b. Now you see this cancels, that cancels, and here x is tending to infinity. In numerator, this is only ax, and in denominator, root over of this plus root over of that. Highest power in numerator is x. In denominator, highest power is x here because it is root over of x square. So x, this is also x. So divide throughout by x, and it would be limit, yes, limit x tends to infinity. I am dividing by x, so that here it is under root. We have to divide this by x, that also by x. So within root over, we have to divide by x square, so that it is a square plus a by x plus b by x square plus root over of same case, it is a square plus b by x square, so that it is equal to a in numerator, a, and in denominator this is root over a square plus 0 plus 0. This is also 0. Something by x or something by x square, as x tends to 0, infinity is 0. So that this is a, and this is root over a square plus 0, that is root, means it is a, that is also a. So half is answer. So answer is that. Next, next problem is limit x tends to infinity 1 minus 4 by x minus 1 whole to the power 3x minus 1. And options are e to the power 3, e to the power 12, e to the power minus 12, and e to the power 6. And that problem was given in the year that. Now, one thing, we have a formula when x tends to infinity, 1 plus 1 by mx whole to the power mx is tends to e. So here we have to adjust in that way, and very easily we get result. This is equal to limit x tends to infinity. This is 1 minus 4 by x minus 1. As x tends to infinity, x minus 1, it also tends to infinity. So in numerator, in power, I write it minus x minus reciprocal of that. Negative is there, so I write negative x minus 1 by 4. Now I adjust. It is minus 4 by x minus 1 into 3x minus 1. Now, you see, it is e plus 1 by mx, this is minus of that, so it's reciprocal with sign. So this is equal to e into limit x tends to infinity minus 4 into 3x minus 1 by x minus 1. Now here x tending to infinity. In numerator, maximum power of x is 1. In denominator also 1. So now divide throughout by x e to the power limit x tends to infinity minus 4 into 3 minus 1 by x divided by 1 minus 1 by x. Now 1 by x, it must be 0 as x tends to infinity. So that it is equal to e to the power minus 4 into 3 divided by 1. So e to the power minus 12. So that option is correct. Next problem. Fx is equal to box x, integral part of x, plus box of minus x if x not is equal to 2, or fx is equal to lambda if x is equal to 2. If x is equal to 2. Next, if fx is continuous everywhere, then if fx is continuous at x is equal to 2, then value of lambda is lambda. Options minus 1, 1, 0 and 2. This is a question of continuity. Given that that function which is defined in that way, if x not is equal to 2, then this is this plus that. If it is x is equal to 2, then it is lambda. So we have to find the value of lambda if the function is continuous at x is equal to 2. So at x is equal to 2, as because it is continuous, so f2 must be equal to left hand limit is equal to right hand limit. When we get left hand limit, means when x is just less than 2, so we can obtain the value from here. Last day I tell you that box x is equal to its integral, we have to take its integral value if it is positive. Then when x is equal to, x tends to 2 minus, that is x is equal to 2 minus h. H is very small, but it is still less than 2. So that it is box of 2 minus h. That is its integral value is 1. So that left hand limit, that is f2 is equal to, f2 means when x is equal to 2, it is lambda. Lambda is equal to left hand limit. Left hand limit is, its left hand limit is when x is equal to 2 minus h, it is less than 2, so it is 1. Minus, plus, it is box of minus x. Minus x means 2, value of x is 2 minus h. So it is minus 2, minus 2, minus x means plus h. So that its value, it is actually less than minus 2, say minus 2.1. So it is less than minus 2. So its value will be equal to uh, we have to take the integral value. So it is again minus, this is again, oh, just 1 minute. Hmm. Okay, all right. So box box of 2 minus. So it is actually equal to minus, it is minus of x, means x tends to 2 minus h. So that it is box of minus 2 plus h. That is, it is uh, greater than minus 2. Greater than minus 2. That is, it would be equal to, uh, say, minus 2.1. Minus 2.1. So, when x is, value of x will be, integral part of x will be, this is equal to 0. If 0 less than 1, it is equal to minus 1. If 0 less than or equal to, not 0, 1 less than 2. So this is actually 2 minus h. So it is actually equal to minus x. So minus 1. Just just a minute. I'm little bit confused. Achha, just 1 minute. For right hand limit, it would be equal to, we have to take x is equal to 2 plus h for right hand limit. 2 plus h means more than 2. So that it is equal to, this one is, box x is 2 plus box of minus x, means box of minus 2 minus h. So that it is equal to minus 2 minus h, means minus 2 uh, minus 2.1. So that it is equal to minus 2 minus 1, and it is equal to left hand limit is, once again I am discussing left hand limit. The box of x, x is actually equal to 2 minus h. So box of 2 minus h plus box of minus, means minus 2 plus h. So that it is equal to less than 2, so 1, and it is less than, so it is actually 0. So that this is 0. So we get lambda is equal to 1 plus 1, and left hand limit, and right hand limit also 1. So left hand limit 1, right hand limit 1. So limit exists, and for continuity at x is equal to 2, it must be a lambda. So lambda must be 1, so that the function is continuous at x is equal to 2. So this is answer. Next one. The next day, I discuss this problem in a simple way. Okay. Another method in simple way. Next problem. Limit x tending to pi by 2 a to the power cot x minus a to the power cos x. This is cot, this is cos, divided by cot x minus cos x. Options: log of pi by 2 base e, log of a base e, 4 and a. And the problem was given in West Bengal Joint Entrance in 2007. So the problem can be written as limit x tending to pi by 2, take a to the power cos x common from numerator. So a to the power cot x minus cos x minus 1 divided by cot x minus cos x. For that purpose, power of this become equal to that. That's why I have taken this common. Now as x, let us take cot x minus cos x is equal to y. As x tends to pi by 2, cos x 0, this is 0. So y, as x tends to 0, pi by 2, then y tends to 0. So this become limit y tends to 0. Okay. I write first a to the power y minus 1 by y into, now I write this, limit x tends to 0 a to the power cos x. This is nothing but log a base e into, this is a to the power x tends to 0 e to the power cos 0 means a to the power 0 is 1. So that log a base e is the correct answer. This one is correct answer. Okay, today is up to this. Today is very hot. So next day we'll take few more problems.